Welcome to our tutorial for question number 4 of our daily review. Question number 4 is working with exponents and exponential form, and so today we're going to talk about some exponent rules. However, before I do that, I also want to just clarify the idea of simplifying exponents or exponent rules. In this case, if you were to ever see an exponent like 3 to the 6th power, and this is an exponent that we've worked with before, we could write this in expanded form, and we know that all exponents are repeated multiplication, so we would have our base number being multiplied by itself however many the exponent is, in this case 6. So 3 times 3 times 3 times 3 times 3 times 3. Now, we have exponential form and we have standard or expanded form. Neither of these are simplified yet. In order to simplify this, we would want to get the answer. And anytime you see something that says simplify and it's working with exponents, if you can get an answer, we would like to write that answer down. Next, let's go ahead and talk about some of the exponent rules, and there are 4 exponent rules that we will cover today. The first exponent rule is called the product rule, and the product rule is working with multiplication and exponents, and it tells us that when 2 powers with the same base number are being multiplied together, you can add the exponents together and keep the base the same. So let's go ahead and take a look at an example of this. If I had 3 to the 6th power times 3 to the 4th power, we're going to notice that the bases of those two things are the same. And if those bases are the same, well, I can simply add those exponents together, which would be 6 plus 4 equals 10. And then if I was asked to simplify, I could still simplify this problem. And we know exponents get really large really quick. We're at 59,049. Now, if we're wondering why that number is so big, we could think for a moment about the individual pieces of the first problem. 3 to the 6th power, we know, was 729. And we would be multiplying that by 81, or 3 to the 4th power. In this case, giving us the same answer of 59,049. Now, all of these exponent rules are helpful anytime we see bases that are the same. But they will become especially helpful later on in your math career and later this year when we start working with variables and exponents. For example, if I were to see something like this, x to the 6th power times x to the 4th power, unfortunately, I couldn't simplify this all the way down to an answer because I don't know what the value of x is. But I could make it a little bit simpler by using my product rule. Because the bases are the same, I can keep that base and simply add those exponents together and simplify this down to be x to the 10th power. Let's go ahead and look at our next rule. Our next rule is our quotient rule. And our quotient rule tells us that when 2 powers with the same base are being divided, we can subtract the exponents and keep the base the same. In this case, I've given us the same powers, but this time we're dividing. So we have 3 to the 6th power divided by 3 to the 4th power. In this case, we notice that the bases are both 3. They are the same. So we can simply subtract those exponents and make this a little simpler. So 3 to the 6th minus 4 power is the same thing as 3 to the 2nd power. And we know that 3 to the 2nd power is going to equal 9. Now, again, if we want to look at why that works, well, we know that 3 to the 6th power is 729. We've done that several times. This time we're dividing by 3 to the 4th power, which is 81. And 729 is equal, 729 divided by 81 is equal to 9. and that matched our 3 to the second power, which is also equal to 9. Now again, just like in our product rule, we can use this when we're working with variables. In this case, I could choose a variable like w, and if I said w to the 16th power divided by w to the 4th power, well, I'm going to notice that the bases are both w, so I can keep that base the same and simply subtract those two exponents to get from each other. So 16 minus 4 is equal to 12. Let's go ahead and talk about our next exponent rule. Our next exponent rule is the power rule, and the power rule is when a power is being raised to another power, we're going to keep that base the same, and we're going to multiply the exponents together. Let's go ahead and continue to work with some of those same things that we've been working with. In this case, we're going to have 3 to the 6th power. But this time, we're going to raise 3 to the 6th power to the 4th power. Well, according to this, anytime I raise a power to another power, I'm going to keep the base the same and multiply those exponents together. So in this case, that would give me 3 to the 6 times 4. And I know that 6 times 4 is 24, so this would be 3 to the 24th power. Now, we've talked about exponents getting really big really quick. That is already 282 billion, and there's more digits there. I just can't fit them all in. But we're already into the billions, hundreds of billions, in fact. Now, again, if you're wondering why our numbers are doing what they're doing, well, let's take a look. We've worked with 3 to the 6th power a lot. We know that that's equal to 729. And if that is being raised to the 4th power, that would look like 729 times 729 times 729 times 729. And again, the answer to that is in the 282 billions. And just like we've talked about before, this can become really helpful when we are working with our variables later on in this year. So when we see something like y to the 3rd power to the 5th power, we can simplify that to y to the 15th power. Let's go ahead and talk about our final rule. And our final rule is our negative rule, or you might also like to think about this as a fraction rule. And this is any number that's being raised to a negative exponent can be rewritten as its reciprocal with a positive exponent. And we can do this in reverse as well, and so we can work with fractions while we are doing this. In this case, if I had a number like 3 to the negative 6th power, it's a lot easier in general to work with positive exponents. So what we can do is we can turn this into the reciprocal. And if you don't remember what that word means, it means that we're going to flip our fraction upside down. In this case, we started with a fraction of 3 over 1 to the negative 6th power. And now we're going to flip that upside down and make it 1 over 3 to the 6th power. And the great thing is that once we flip it upside down, we can get rid of that negative exponent. So in this case, we would end up with 1 over 3 to the 6th power. And since we've worked with 3 to the 6th power so many times, we know that this could simplify down to 1 over 729. Another example of this is we said that we could do this in reverse. So if I started with a fractional exponent, like 1 over 5 to the 3rd power, I could also flip this around and write it as 5 to the negative 3rd power. Both of those things are describing the same number. And just like we've talked about with all of our other exponent rules, this becomes really helpful when we begin to work with exponents and variables. So if I had something like a to the negative 7th power, another way we could write that is 1 over a to the 7th power. I hope that gives you an idea of how to work with our exponents. And remember to use the descriptions to help you find the specific spot that you're looking for.